Greetings, folks. Welcome. The practice of statistical inference involves, you guessed it, using information from a sample to say something about a larger population. And a common application of statistical inference is using information from a sample to test a claim you might have about a population mean or population proportion. This is what we call a hypothesis test. So I have this claim that I think that students study more than an average of 5 hours per day. So to test this claim, I'll do what's called a hypothesis test. The first step is writing out my hypotheses. So my alternative hypothesis, which is a statement of my claim, is that mu, which is the population mean, is greater than 5, versus my null hypothesis, that that's not the case. So for it not to be the case, the mu, or the population mean, would have to be less than or equal to 5 hours per day. As a researcher, I'm deciding that I'm going to use an alpha, or significance level, of 5%. The significance level means that I'm willing to tolerate a 5% chance of making a mistake, of rejecting the null when the null is true. So now I have the fun part of collecting the data. So I talked to a random sample of 30 students and found that they study an average of 7 hours per day with a standard deviation of 4 hours. With this information, I can calculate a test statistic. Since it's a hypothesis test about a population mean value, my test statistic is a t-statistic. It's equal to 2.74. So that's found by taking the value from my research, or the sample mean value of 7, subtracting from that 5 hours, which is the value from the null hypothesis. We can divide this by the standard error of the sampling distribution for a sample mean. That's equal to S divided by the square root of n, where S is a sample standard deviation, which is 4. You divide that by the square root of 30, which is my sample size. So I interpret that test statistic of 2.74 to mean that the value for my research is 2.74 standard errors away from the null hypothesis. If you got a small value for the t-statistic, let's say 1 or maybe even a half, that would tell you that the value from your research is pretty close to the value from the null hypothesis. But with the t-statistic of 2.74, my research tells me that what I'm finding is pretty different than the null, so chances are we'll be able to reject the null. The fourth step of a hypothesis test is finding the p-value. The p-value gives you an indication of the strength of the evidence for the null. So if you get a small p-value, then you're more likely to reject the null. So to find the p-value, we have to go to the t-distribution table. And remember, our test statistic was t equals 2.74. With a sample size of 30 observations, we have 29 degrees of freedom. So I'm looking on my t-distribution table for the value of 2.74 with 29 degrees of freedom, and crap! I can't find it. I can't find 2.74. Oh, I'm going to fail. Rats. Did one of you mess with my t-distribution table? Did one of you fool with it? I don't know. I think you maybe did. Okay, so I've got 29 degrees of freedom. I can't find a t-statistic of 2.74, but what I can find is 2.462 and 2.756. So what this means is that the value for 2.74 is somewhere in between those two. So it's somewhere in between 0.5%, which is 0.005, and 1%, which is 0.01. So what this tells me is that the p-value, or the strength of the evidence for the null hypothesis, is somewhere between 0.5% and 1%. So what this means is that if the null were true, there's between a 0.5% and 1% chance that I would have found from my research a t-statistic that's equal to or greater than 2.74. In other words, if the null were true, it's very unlikely that I could have found the test statistic that I found. So what that means is that it's unlikely that the null is true. The fifth and final step of the hypothesis test is comparing the p-value that we just calculated to the significance level that we set in step 2. So you might recall that with a significance level, or alpha, of 5%, we are willing to tolerate a 5% chance of rejecting the null hypothesis when it's true. But with a p-value of between 0.005 and 0.01, there's between a 0.5% and 1% chance that if the null was true, that I could have gotten a test statistic of 2.74 or higher. Since the p-value is less than alpha, we can reject the null hypothesis in favor of the claim. In other words, we can say that with a 5% significance level, and based on our sample of 30 students, we can conclude that students study more than an average of 5 hours per day. So more generally, the rule for whether or not you can reject the null hypothesis is if the p-value is less than or equal to alpha. Again, the p-value is something you calculate based on your test statistic, whereas the alpha is something you set as a researcher. But if the p-value is less than or equal to alpha, you reject the null hypothesis in favor of your claim. On the other hand, if the p-value, again, the p-value is the strength of the evidence for the null. If that's greater than the alpha value that you set as the researcher, you cannot reject the null hypothesis in favor of your claim.